Funding for this program is made possible with the support from the James and Barbara Semino Foundation, Ann Balakay and Louise Nelson, Judy and Steve Meyer, and from contributions to the Friends of Idaho Public Television and viewers like you. Thank you.
On March 30th, 1953, in the high desert plains of Idaho, a group of men inside a rectangle-shaped, 6-story concrete building, surrounded by miles of sagebrush, are preparing to test a prototype naval reactor. This nuclear reactor was built for a submarine, the Mark I, a pressurized water thermal reactor built by the newly formed Nuclear Power Branch of the U.S. Navy, and the Atomic Energy Commission, was developed and built in just 3 years. This had never been done before. Nuclear energy was still mostly theoretical in 1953. The man in charge, Captain Hyman G. Rickover, was prepared for either the success or failure of the naval reactors program.
Rickover believed that you needed to actually operate an actual nuclear power plant and to train on that nuclear power plant.
The Mark I looked like a submarine midsection installed in a round pool of water, with both ends extending beyond the pool on either side. In theory, it was designed to turn a nuclear reaction into heat. That heat would turn pressurized water to steam. That would turn reduction gears. That led to a water break simulating propellers.
And that's why he built the prototype out in Idaho, because he wasn't going to put it into a ship unless he was sure it was going to work. So we built the S-1W prototype, and they struggled at the beginning, but eventually, through hard work, all the kinks got worked out, and he was satisfied to put it on the Nautilus.
A few months later, one of Rickover's top advisors called the success of Mark I, or later known as S-1W, the Kitty Hawk of the atomic age, referring to the Wright brothers' first successful flight 50 years earlier.
There's certain people in history that you know are geniuses, and he is clearly one of those men.
The efforts here in the sagebrush desert would change the U.S. Navy forever. Former President Jimmy Carter pointed out the importance of the Naval Nuclear Propulsion Program at the commissioning of the USS Jimmy Carter in 2005.
He asked everyone in the audience to raise their hand if they believe that Admiral Rickover has impacted their life in any way. And about half the audience raised their hand.
Let me correct those who did not raise their hand.
Admiral Rickover, really the father of the Naval Nuclear Propulsion Program, has really impacted everyone.
It's very likely that every human being who lives in the United States of America, and perhaps even in other nations, have had their lives directly affected by the work and the dreams and the vision of Admiral Hyman Rickover.
Here, 300 miles from the nearest ocean, and the foundation that Idaho has meant for the Naval Nuclear Propulsion Program, we take the best people, we train them, we treat them, teach them the right standards, and then that has carried the legacy forward of powering maritime dominance for 75 years.
This is America's Sagebrush Navy. In 1940, the United States was hesitant to enter World War II. The nation was still struggling to dig out of the Great Depression. Many were still out of work. Breadlines, rampant crime were major issues on the home front. Many national leaders took an isolationist worldview.
We want no war. We'll have no war, save in defense of our own people or our own honor.
Many leaders argued against joining a war in Europe. That changed on December 7, 1941. Responding to aggression by Japan, the U.S. joined the Allied powers.
When Pearl Harbor was attacked, the United States military complex was not like it is today. In fact, it was pretty weak, and the Army and the Navy had to start building up their systems.
U.S. troops had old, worn-out equipment for training.
We had makeshift supplies, makeshift equipment, stovepipes for cannon, bags of flour for bombs, and trucks were labeled tanks.
On the naval side, the United States had a few ships and submarines. Most were old and needed to be refurbished.
What was it like back in World War II? Submarine force obviously added significant value, but they were diesel submarines. And while they had significant warfighting capabilities, they had one Achilles heel. And that Achilles heel was that they were diesel powered and they needed air in order to operate the diesels to recharge the batteries.
The air supply and exhaust system provides for the diesel engine's air intake and exhaust and takes care of ventilation of the ship's compartments.
Effectively, diesel submarines were surface ships that momentarily submerged underneath the ocean in order to be very stealthy in order to conduct their warfighting operations.
The United States military began looking at its Pacific coast defenses, and they realized that a lot of the actual coastal installations were already at capacity. The military realized they needed a few more sort of inland places to process, to train, to make sure that the wartime efforts were as complete as they could be.
There's ties back to Idaho and the Navy with the Farragut Training Center, where basically it was as big as Great Lakes, or nearly as big as Great Lakes, with developing our sailors to fight in World War II. And then we had a gunnery range here where we tested the 16-inch guns.
The U.S. Navy developed the Pocatello Naval Ordnance Plant and the Arco Naval Proving Grounds in Idaho to service large battleship guns that needed to be refit.
Those guns have a very short life once you start firing them. They can only handle so many rounds through before the lining breaks apart. So they have to be refit pretty regularly.
Pocatello was very convenient because it already had U.S. highway access, and it also had the Union Pacific Railroad. So the Navy started there, building the Pocatello Naval Ordnance Plant. Already having an installation in Pocatello, the Navy looked in the surrounding area and found a couple hundred square miles that was uninhabited. It had been attempted to homestead in the early 20th century. That failed when sufficient water couldn't be brought out to the site. So the land was in basically public hands already. The Navy came out, they took control of it, and they built the Arco Naval Proving Ground to test the guns and the ordnance that was coming out of the Pocatello Ordnance Plant. So you have the Union Pacific that comes from Pocatello, as you said, up through Blackfoot, and actually swings out to the west to head through Arco and then up to Mackay. The spur line comes directly off that UP rail line, and it runs just about 5 miles to the concussion wall here.
And they would mount the gun on a stationary platform, and they would fire it to make sure that the lining was fit properly and the gun worked properly.
Anywhere between 3-inch and 16-inch guns could be tested out here. Approximately 15,000 rounds of varying sizes of ammunition were tested over what was basically a 4-year active life out here. An entire railroad spur was built to bring those large guns up. So the rail car would pull up under the 200-ton gantry crane behind me. The crane could lift it up, move it onto the transfer car, and then those guns could be moved out into the gun emplacements for test firing to the north. Those are going to create a lot of air movement as those projectiles are projected out of the muzzle, right? So to prevent that sort of wave of air moving across the landscape, the concussion wall was built, essentially to stop that concussive force and protect the folks who are living just half a mile away.
Post-World War II, the need to test battleship guns was no longer necessary. When the Pocatello Naval Ordnance Plant closed in 1949, the Naval Proving Ground fell silent. It wasn't long, however, before the land would once again prove useful.
Shortly after World War II, the Atomic Energy Commission was formed, and there was a new demand of taking this new technology, nuclear power, and ultimately use it for commercial applications and the potential of using it for naval applications. Back then, what we know as the Idaho National Lab was really a national reactor test facility, and there was a lot of development in that area.
And that is part of what attracted the Atomic Energy Commission in 1949. There was already an installation out here that was isolated in case this new nuclear reactor technology happened to go awry.
Tapping into the resources of the Manhattan Project, the U.S. government wasted no time in advancing nuclear technology. A new focus was on harnessing atomic power.
It was actually competitive at that point. I believe Montana was in the running, but ultimately we decided that it was in an area that was already being utilized for testing purposes, and it was also the national drive. So both of those were critical for the decision of where that was made.
And there was this idea that, we can make an explosion, but if we can control that radioactivity, there's more we can do.
The atomic energy movement was pursued by the United States and the Soviet Union. The United States was determined to be the first to show the world it could harness the atom to create usable amounts of electricity from uranium. The National Reactor Testing Station was established in 1949 using the old Naval Proving Ground in the Arco Desert.
Here there are more reactors of more advanced and different types than in any equivalent anywhere. This rolling desert plain has been nicknamed Prototype Prairie.
Argonne National Laboratory under Walter Zinn was working on an experimental breeder reactor, EBR-1. A few miles away, the United States Navy had a similar project in the works.
In 1946, a group of naval officers and civilians were assigned to work on the Manhattan Engineered District's Daniels Power Pile project at the Clinton Laboratories, now the Atomic Energy Commission's Oak Ridge National Laboratory, Oak Ridge, Tennessee. Senior member was Captain, later Vice Admiral, H.G. Rickover, a qualified submariner and engineer with a strong faith in both the practicality and necessity of atomic propulsion.
Hyman G. Rickover was a Navy captain who had little regard for naval etiquette. Rickover was an immigrant from Russian-occupied Poland. His family moved to the United States in 1906, arriving at Ellis Island. His family moved around looking for work. In 1918, as a teenager, Rickover applied to the Naval Academy.
Admiral Rickover also went to Annapolis, but he didn't like Annapolis. He wasn't treated very fairly when he went to Annapolis.
After the academy, Rickover was assigned to serve on a destroyer and later a battleship. Both times he was designated engineering officer. He threw himself into the work. A captain once said he had no outward signs of qualities of leadership, but he got results. Rickover then returned to the Naval Academy, then Columbia University for a master's degree in electrical engineering. He was promoted to lieutenant. Lieutenant Rickover tried to volunteer for submarine service, but was denied due to age. A former commander interceded on his behalf, and he served on 2 diesel-electric submarines. In 1937, Lieutenant Commander Rickover was given command of a rusty minesweeper built in 1918. It was hardly the command Rickover felt he deserved. Feeling like his career had moved in the wrong direction, he applied for engineering duty only status. His request was approved just 3 months after assuming his first and only command. Promoted to captain, he moved to the Bureau of Ships at Maine Navy, a sprawling complex of buildings in Washington, D.C. The buildings were just off the National Mall. In 1946, the Navy sent Captain Rickover to Oak Ridge National Laboratory to explore nuclear energy for naval applications. It was here he got a crash course in nuclear fission.
He believed that nuclear power could offer a warfighting advantage So he created an organization starting with a lot of learning that went on in 1946. But the organization partnered with the Atomic Energy Commission and set out to lay the groundwork for having a nuclear-powered submarine.
In 1947, the Atomic Energy Commission started overseeing nuclear energy development in the United States. 1 year later, on August 4, 1948, the U.S. Navy created the new Naval Reactors Branch within the Bureau of Ships Research Division. Captain Rickover swiftly asserted authority and initiated plans for the S-1W prototype and the first nuclear-powered submarine.
You know, he always said building something new like that is 99% perspiration and 1% inspiration.
You know, we might say now that he was obsessive compulsive. And he was able to lead his people that way too.
Rickover was often in a suit and tie, a sign he put his faith in the work and not Navy tradition. Captain Rickover served two agencies, one with the Navy developing a reactor, the other as a Navy representative at the Atomic Energy Commission that controlled nuclear materials. He found he could use both to get approval for his projects. Once a plan was developed on paper, the captain required it to be real-world tested. The Navy's Bureau of Ships was resistant to helping build his reactors. Commanders were less than eager to work with Rickover, so he leaned on General Dynamics' Electric Boat to do the heavy lifting.
So he got together with General Dynamics, and they together kind of worked their way through how do I miniaturize all of this stuff that I have here.
At the time, two different reactor designs were being developed. A pressurized water reactor, the STR Mark I for the Nautilus, and a liquid sodium-cooled reactor, the Submarine Intermediate Reactor Mark A for the future Seawolf. The water reactor plans were full speed ahead by 1949. The reactor group built a full-scale prototype at the National Reactor Testing Station.
The Navy, with the federal government, brought in the best of breed out there. We brought in Electric Boat to create and build the S-1W prototype. We brought in the Argonne National Laboratory to do design work on the reactor plant. We brought in the Bettis facility in Westinghouse to design the propulsion plant.
One hurdle Rickover faced was finding parts for the reactor prototype. This had never been done before. Rickover demanded the parts be built from scratch from the highest quality materials. He knew if the reactor was going to survive combat, it needed to be robust. He wasn't going to sign off on parts unless they met his rigorous standards.
When he stood up the nuclear power program, he needed industry to produce components with precision and high quality. At the time, the industry didn't think they could do that. He had to create the authorities and responsibilities and get all those aligned with the resources to do this, to deliver nuclear power for the nation. But because of his persistence and demanding nature, he was able to achieve that, and that sets the foundation for everything that we do today.
The submarine thermal reactor became known as S-1W, reflecting the reactor was built by Westinghouse.
The S-1W prototype, submarine first generation Westinghouse, was the proving ground for the Nautilus. It allowed us to prove out the concepts, to work on the equipment locations in a tight, constrained hull, to prove out the shielding and to prove out that all of the components were going to work.
On December 20th, 1951, nuclear fission was successfully used to illuminate 4 light bulbs at the experimental Breeder Reactor 1, marking the first time electricity was generated by a nuclear power plant. Although the amount of electricity produced was minimal, the achievement demonstrated the feasibility of nuclear power and represented a significant milestone for the United States. Meanwhile, just a short distance away, development of the S-1W naval reactor prototype was well underway.
EBR-1 had already lit lights. He wasn't worried about that. He wanted to see, can it fit inside of a submarine?
I think if you take a look at the beginning of the program, they were actually considering putting it on a destroyer to start with, but then when they realized that it was much more challenging to put on a submarine because it's much smaller, much more confined space. Submarines are inherently more risky than a surface ship as far as operating, but when you could put a nuclear propulsion plant on, you gave the submarine tremendous flexibility, and that's what Nautilus did.
So they didn't just build a reactor, they built a reactor and put it in the shell of a submarine engine room. Because he wanted to see how are the engineers going to work with it. Are they going to be able to get to different pieces? Can it be done safely? What happens when you have a problem? Where are your procedures going to be out in the middle of the Atlantic? So he set that up for S1W, and the development time was insane.
There was a pool of some 300,000 gallons that surrounded the prototype, and that was to test all the interfaces with the sea.
In March 30th of 1953, S1W went to critical for the first time, and believe it or not, that was only 70 years ago. After some reactor physics testing, the S1W prototype then went to full power operations, and that simulated a submarine going full speed across the Atlantic. And that was a game changer compared to what a diesel submarine could do.
Later that same year, President Eisenhower was pushing the world to focus nuclear research on power, not bombs. It was known as Atoms for Peace.
The United States knows that peaceful power from atomic energy is no dream of the future. That capability, already proved, is here, now, today. A special purpose would be to provide abundant electrical energy in the power-starved areas of the world.
Early tests showed the prototype reactor worked, but in true Rickover fashion, he wanted to push it to its limits. Only then would he know if it would operate safely.
The S1W prototype operated at 100% reactor power for 66 days, and that was equivalent to circumnavigating the Earth twice. Pretty amazing accomplishment, and that really proved the viability of nuclear power in a warship.
Meanwhile, the United States was in an intense geopolitical competition with the Soviet Union. The Soviets were quick to downplay the U.S. Navy tests as groundless, a plan to frighten people with weak nerves. The Red Star, a Soviet newspaper, claimed the reactor was just a steam turbine with an electric motor. But Rickover knew better. S1W was instrumental to the development of the nation's first nuclear-powered submarine, the USS Nautilus, which was commissioned in 1954 and departed the shipyard in Groton, Connecticut in 1955. Its captain, Eugene Wilkinson, handpicked by Rickover, made history by communicating underway on nuclear power. In 1958, the Nautilus was selected to sail under the polar ice cap, a mission previous submarines had tried and failed. An earlier expedition used a modified O-class submarine that had been removed from the U.S. Navy registry in 1924. USS O-12 was subsequently renamed Nautilus as a nod to a book written by Jules Verne. It was leased by Sir Hubert Wilkins for an expedition to sail under the polar ice cap in 1931. Loaded with supplies and scientific equipment and a crew of 20, the boat set sail for the polar ice cap. But it was a miserable journey. Cold, leaky, and with failing equipment, this early Nautilus only managed to go a short distance before having to turn back. It was considered a failure. In 1957, the Soviet Union had beat the US to space and launched Sputnik 1, the world's first artificial satellite. President Eisenhower needed a win, so he commanded the US Navy to send the nuclear-powered Nautilus to the Arctic.
The Nautilus was terrifying for the Soviet Union. It sailed underneath the polar ice cap without having to surface, and their submarines couldn't follow it. The United States had this ship now, or this boat, that could go out, get right up on the Soviet Union's front doorstep, and they wouldn't have any idea. It was a strategic move as much as it was a technical move.
The very first nuclear ship ever made, the Nautilus, a nuclear submarine that Dwight Eisenhower used to send from the Pacific Ocean to the Atlantic for the first time ever under the Arctic. The world said, my word, the United States is back. It's the leader in science. It's the leader in the military.
The second nuclear propulsion plant prototype in Idaho, A-1W, aircraft carrier first-generation Westinghouse, had 2 reactors and began operations in 1958.
As Nautilus is underway on nuclear power in 1955, we commenced building A-1W in 1956. The first reactor went critical in 1958, and the second reactor went critical in 1959, taking that to full power. And that was a prototype reactor to both test surface ships and aircraft carriers. And then we went on to design Enterprise, state-of-the-art, one-of-a-kind, 8 reactors on USS Enterprise. Incredible performance.
When you look at the USS Enterprise, it was to have 8 reactors and 4 engine rooms. So he wanted to mock that up. Where are we going to put the reactor? How are we going to shield it? We're going to have a lot of heat off of it. How's that going to affect the crew? How can the engineers get to the reactors and run them in tandem? It's these questions that he wanted to solve in that environment that was completely controlled before he tried to build a ship.
Nuclear reactors create power by utilizing a controlled nuclear chain reaction by moving control rods in and out. That produces heat that turns water to steam. Steam drives the turbines that are connected to generators and the propellers. Steam is also used to launch aircraft off the deck of a carrier, towing aircraft from 0 to 120 miles per hour in just 2 seconds.
It was light years ahead of what anybody else could imagine doing with technology.
In 1959, the Navy put 2 nuclear reactors on the USS Long Beach, a guided missile cruiser. The first and only ship of its design, the USS Long Beach had a familiar face when it launched.
That was Eugene Wilkinson on Nautilus, and then he was the commanding officer on Long Beach when Long Beach was actually commissioned and underway.
In 1962, the U.S. Navy commissioned the USS Bainbridge, a 3rd nuclear-powered surface ship. To celebrate the remarkable achievement of nuclear power, the U.S. Navy embarked on a world tour known as Operation Sea Orbit.
Bainbridge, Long Beach, and Enterprise started off on Operation Orbit in the Mediterranean, and they circumnavigated the world with no need to refuel and no need to resupply. It was really a demonstration of the flexibility of nuclear power, how it gave surface ships and aircraft carriers, which we still enjoy today on our aircraft carriers, because you have that unlimited power of the atom, basically to drive these warships tremendous distances, really only limited by the food you can carry.
Rickover's lack of naval etiquette earned him little support in Washington, but they couldn't deny his success. Operation of S-5G began in 1965. Submarine 5th Generation General Electric is an advanced pressurized water reactor that lets the Navy evaluate the reactor's performance in simulated ocean conditions.
So that's our 5th generation, and he commenced construction on that in the early 60s, and that plant was actually delivered and operating here as a 3rd prototype in Idaho in 1965. And that S-5G, just incredible what that plant could do, because it was on gyroscopes to test natural circulation. So you filled a pool of water and we could operate that and tilt the reactor back and forth just to make sure the natural circulation would work.
Looked like a portion of a submarine set in a basin that would rock and roll. They would fill it with water and rock and roll, but that was before my time.
And we generally had used reactor pumps to push the water through the reactor, through the steam generator and back. But the natural circulation, what that relies on is the heat of the reactor heating up the water, and basically it creates a thermal driving head. Cold water enters the bottom of the reactor, hot water exits, and it just flows without even needing a pump. And that's what we were proving with natural circulation. And we needed to make sure that under all submarine angles that we'd maintain sufficient natural circulation to operate the reactor. So it was revolutionary, and you're talking about that concept and the construction being started 12 years after the founding of the program.
By the time S5G, the third of 3 prototypes in Idaho, was retired in 1995, thousands of sailors had rotated through the prototypes at today's Idaho National Laboratory.
But Idaho's been vitally important to us. It's the birth of our program. It's where we learned about the development of these technologies. It's where we trained 40,000 operators.
Those 3 prototypes gave sailors essential hands-on experience prior to their assignments on fully operational nuclear-powered ships.
Rickover believed that you needed to actually operate a nuclear power plant and to train on that nuclear power plant. And then we showed up out at the Naval Reactors Facility, the S1W prototype. The first 6 weeks was classroom training. It was understanding all of the systems that you were going to have to understand and operate that were unique to the S1W prototype. And so a typical day was about 18 hours. You would sleep, wake up the next day, and go through your training. And you would do that literally until you ran out of food. And then you'd come back on the bus, replenish yourself, and you go back out there.
Not everybody passed. A lot of guys washed out because they didn't have the ability to do the math or they didn't have the mechanical ability.
I do remember getting there in like September of 1988 and leaving in March, and I think I was frozen for the entire 6 months. And I remember getting up, catching the bus at 4 in the morning, and then the 60 miles out to NRF. Then you got off the bus, and in my case, I went to S1W. I think I can draw everything that I learned, almost 35 years ago. That's how good the training was. There was like a little central library, if you want to call it, and you went up there and you checked out a manual or an operating procedure or something like that. You'd take that back and you'd study, and you'd learn about those things, and then you may walk into the actual prototype. I've heard it compared to like a very elite college of 4 years, crammed into 6 months.
Not everyone that went through prototype training were sailors. Some were civilians, like Doug Lenio and Kelly French. Lenio had just finished school at the University of Arizona in 1987.
Westinghouse was recruiting down there, and Idaho sounded like a fun place to be because I like the outdoors. I was one of the first classes to actually be embedded with the naval officers. I qualified on the plant, then turned around and started training Navy students. Now, you've come from nuclear power school where they've trained you on the theory behind everything, so you understand that, but now you're looking at the actual systems that you've looked at on paper, and you're looking at all these piping systems and electrical wires, and you're trying to think, oh my gosh, I gotta know how all this works and where everything is, and it's somewhat overwhelming at first. What people may not realize is how noisy of a place it was. Because when the plant's operating, you have all kinds of rotating equipment. There's a unique smell inside of a prototype, having to do with a lot of the oils that are used in the machinery, and those get into some of the lagging. It gets in there and it sort of creates this smell that's very unique.
I served at S1W from February of 1983 until the final shutdown, and a little bit beyond February of 1990. I then transferred to the S5G prototype, where I qualified again as Engineering Officer of the Watch.
The sailor training program ended in 1995, but today the Naval Reactors Facility is still active, researching spent fuel from naval vessels and processing the fuel for shipment to a nuclear waste repository.
There's only one place that will process that fuel, and that is at the Naval Reactors Facility. And That is basically taking that spent fuel and placing it in a road-ready condition to take it to the National Repository. Absolutely critical part of the mission. As long as there is a nuclear-powered fleet, there's going to be a naval reactor facility in order to process that fuel.
What was learned in Idaho helped naval reactors improve the design of the USS Enterprise. For the new Nimitz-class carriers, like the USS Dwight D. Eisenhower, which remains in service today. Advancement in technology reduced the number of reactors to just 2. These supercarriers are floating cities carrying a crew of 5,000 along with a complement of aircraft.
It's incredible what that ship has done. It is operated in the Middle East right now. It is projecting America power and supporting global trade. And that carrier is going to be replaced by a brand new Ford-class carrier called the Enterprise to replace our previous Enterprise name. But that carrier is going to have 30% more power, 25% more power density in it, so it can operate longer.
The old Enterprise was retired in 2017. A new Enterprise is already being built in Newport News by Huntington Ingalls Industries. It will add the U.S. complement of supercarriers in the Ford class, replacing the Nimitz-class carriers like the Eisenhower.
We reduced the crew by about 600. Our engineering department is actually half the size. It's going to save billions of dollars, and it's a tremendously capable aircraft carrier. The USS Ford, first of its class, just came back from its first deployment, and it was incredibly successful what that carrier can do.
Congress appreciated Admiral Rickover's no-nonsense attitude. That attitude was often in full display for the endless line of officers that had to be interviewed by him before being accepted into the program.
There's a story about Admiral Rickover. He said to the interviewer, "Make me mad," so the person doing the interview grabbed a model off his desk and smashed it right in front of him.
He said, "How do you stand in your class at the Naval Academy?" And I swelled up with pride. I had done fairly well at the Naval Academy. Then he said, "Did you do your best?" And I thought about the time I was at the Academy, and I didn't know what to say. And finally, I looked at him and I said, "No, sir, I didn't always do my best." And he stared at me with cold eyes. And finally he said, "Why not?" I sat there for a long time. And then he turned his chair around to end the interview and began to work on some papers on a table behind. And I finally got up and stumbled out of the room.
So then he goes, "What the hell do you do?" And I said, "Well, I'm the deputy brigade commander." And he goes, "Well, what the hell does that mean?" And I said, "Well, I'm in charge of the brigade activities committee." And he goes, "What the hell does that mean? Do you motivate people?" I said, "Yes, sir, I motivate people." So then he said, "Aardvark, get in here." And he had these names for all his secretaries. So this lady came in and she sat down and he looked at me and he said, "Go ahead, Walsh, motivator." And I was kind of taken aback. I didn't know exactly what to say. And he started screaming at me, telling me I was nothing but a quitter. He said he looked in my eyes and he knew right away I was a quitter. So it was a interesting interview.
There's another story about how somebody getting an interview tried to walk out of Admiral Rickover's office and walked into the closet. So Admiral Rickover left him in there for a couple hours before the individual actually got out. So there's a lot of great stories about him.
Telling him what I thought he wanted to hear rather than, and he could recognize that right off the bat. So I can get out. So I got put in a closet for about 4 hours, mops and stuff.
If you weren't in the closet thinking about your transgressions, you were in the chair across from the Admiral, a special chair.
With 2 front legs a couple inches shorter, just to make you uncomfortable when you were interviewing with Admiral Rickover, such that he could really test your mettle on there.
If I could pick one thing that I think Admiral Rickover did that is as much alive today as it was when he was running naval reactors, is his insistence on excellence and accountability.
Over Admiral Rickover's 34 years as head of naval reactors, he made friends and enemies. As longtime supporters left Congress and friend and former submariner President Carter lost to President Reagan in 1980, Rickover was vulnerable. He was allowed to stay on active duty for 2-year extensions approved by Congress. When President Reagan took office in 1981, his administration began working to force Rickover to retire. Many believe Rickover to be untouchable. However, a year later, Rickover was forced to retire in 1982. But nobody could take away the legacy of reactor safety and quality he developed over 3 decades.
And you look at what it does for our Navy, our nation, and really world security, it's incredible. And it's really due to Admiral Rickover's drive, commitment, and I'd also say his impatience. It's the longest tenure of any member of the military, and his commitment to excellence and his drive is what has really carried the Naval Nuclear Propulsion Program.
Today, the head of the Naval Nuclear Propulsion Program serves a total of 8 years in office, the longest tenure of any U.S. military flag officer. This program, America's Sagebrush Navy, began under Admiral Caldwell, who retired in 2024. Today, the head of naval reactors is Admiral William Houston.
The typical max is 4 years for a flag officer. That's generally the longest, but the director of naval reactors is 8 years. It's not just a Navy assignment. I'm dual-hatted. I work for both the Navy and I also work as part of the Department of Energy, because it's really taking that nuclear propulsion plant and harnessing it for military application is what Naval Reactors does. And that 8-year tenure, Admiral Rickover had a 34-year tenure on it, and every director since then has been tenured for 8 years. And it's really because of the consequence and the importance of the decisions you make when you're dealing with nuclear propulsion. You really have to understand that cradle-to-grave responsibility we talk about, from designing a reactor to the final disposal of that propulsion plant. So it's a tremendous responsibility that you carry on both the Department of Energy and the Department of Defense.
Nuclear power provides our Navy with phenomenal warfighting advantage. But we have to respect the power in reactor. We have to treat it with the proper stewardship and the proper respect. Our sailors live right next to a nuclear reactor. They live and function near a nuclear reactor every single day. So to do that, we have to design a system that is conservative by design. And we can only do that by the trust that's been established and enabled. And that trust is centered on, as I said, protecting our sailors, our workers, the local populations, and the environment. There has never been a reactor accident in the Naval Nuclear Propulsion Program, and nor has there ever been a release that has affected the environment.
The 3 prototypes are in the process of being demolished. After an extensive cleanup of the reactor and dismantling of internal components, the concrete facade that had stood since the 1950s was taken down the summer of 2025. A1W was turned over for demolition that same year, and S5G will be dismantled soon.
What Rickover did in the Arco Desert changed the nation and changed the world. What he did in those buildings was truly historic. Every bit as historic as EBR-1. The question is, well, why tear them down? Why can't we leave them there and use it for education? Well, these were nuclear testing facilities. And so you have contamination. You know, they were bringing in cores, taking out cores. They operated for decades, and the United States requires that we clean up our messes.
Before cleanup of the 3 prototypes could begin, the Naval Reactors facility had to take preservation into consideration. It's a federal requirement under the National Historic Preservation Act of 1966. Signed into law by President Lyndon B. Johnson, the act requires federal agencies to make preservation of historic artifacts part of an agency's work.
if a federal agency has an undertaking that has the potential to impact historic properties, they have to take into consideration those properties in their decision-making process and work with our office through a consultation process to try to avoid, minimize, or mitigate any adverse effects to historic properties. The most commonly known of which is probably the National Register of Historic Places. That is the official national list of those properties considered important in our past and worthy of preservation.
Years before demolition work began, the staff at the Naval Nuclear Propulsion Program met with the Idaho State Historic Preservation Office to figure out how to preserve the tremendous history of the prototypes.
Mitigation is what all parties can agree to. So that's what we try to do. We try to make it a win-win for the community and a win-win for the resource and a win-win for the entity that has to do the project.
So in this case, with the project at the NRF to remove the nuclear naval prototypes, that's a pretty big impact. Those are unique, one-of-a-kind properties that once lost will be gone forever. And so we went into consultation with the NRF staff and other parties, other interested parties, from a position of, this is a pretty big impact and we need to make sure that the consultation results in mitigation that's commensurate with that impact.
One of the things that's so amazing about INL is this huge site, and it's been protected for a long time, so the resources there are quite pristine. So often when the INL team has to look at their role in implementing the National Historic Preservation Act and all of the requirements that federal agencies have, they're very good at it and they know to call our team.
The NRF conducted oral histories with sailors who had been through the program, and they sought them out nationwide, which was terrific. I believe we have 30 oral histories from former sailors that are going to be accessioned into the Idaho State Archives now. This was critical, of course, because many of them are reaching an age where we're losing them, more and more. And so that was, we felt, a really critical piece of telling the story of the site, was getting that first-person experience to share.
And so at S1W, they had the water break, which was, you'd have a guy stationed out there and his job was to adjust the pressure on a paddle wheel to simulate sea pressure so that you don't cavitate.
You're going to get qualified in 24 weeks or 26 weeks. This is how many points you need each week to stay on the curve.
As long as you're ahead of the curve, life is reasonable. You get behind the curve, then there's percentages. It's positive encouragement delivered with a baseball bat.
S1W was a choice assignment, relatively simple. Even I could understand it. And the Admiral Rickover used to call it his little tea kettle because it was simple, rugged, and reliable.
While the prototypes in Idaho won't be around for long, the boat S1W was built for, the Nautilus, is still around. Nautilus was decommissioned in 1980 and designated a National Historic Landmark in 1982. After extensive work to remove the reactor core, she was towed to Groton, Connecticut in 1985. The following year, Nautilus was opened to the public as a museum. Visitors can see where sailors once ate meals and the small bunks where sailors slept. Outside the captain's quarters, an original copy of French writer Jules Verne, 20,000 Leagues Under the Sea, is enshrined under glass. Close to 250,000 people visit Nautilus every year.
It's important that we preserve our history, not just history you read about in a book, but history that you can walk through, that you can touch, that you can smell and feel. That's what's important about these types of programs that preserve our history.
Just down the road from the Nautilus at General Dynamics Electric Boat, a new Virginia-class fast-attack submarine is being built. In 2015, the U.S. Navy announced this new submarine would be named for the state of Idaho.
You have three milestones that are very important and crucial to
for a boat, right? For in this case, a submarine, into the Navy. First, you start with the keel laying, and although submarines don't have a keel, it's called a keel authentication. That starts the process of the shipbuilding.
The keel for the new boat was laid down in 2020. The sponsor of the future USS Idaho, Terry Stackley, christened the boat in 2024.
In the name of the United States, I christen thee Idaho. May God bless her and all that sail in her.
Alwyn Morales is the protocol officer with the U.S. Navy at Naval Base New London in Connecticut.
Protocol officers pretty much looked at ethics of how we do ceremonies, make sure that they're done properly.
The Navy has a proud tradition of accepting ships and boats into service. Once a submarine has a keel laid, it begins construction. At a certain point in construction, the boat is officially named.
Then you get to the christening, and that's the very famous, you see a lady breaking the bottle, the sponsor of the ship, breaking the bottle on the hull of the ship, naming officially the ship.
The tradition for selecting a ship's sponsor predates the U.S. Navy.
It goes back to the wooden ships, where you have a female name the ship, and in the process, the thought has always been, right, the tradition is that the ship gets imbued with her attributes, personality, you know, all the things that are good about that person.
Sponsors are chosen to bestow luck on a ship or boat. That sponsor is unofficially a permanent member of the crew. Past sponsors include Mamie Eisenhower for the USS Nautilus in 1954, and Eleanor Rickover for the USS Hyman G. Rickover in 1984.
You know, I was the commanding officer of the Hyman G. Rickover, and Eleanor Rickover was our sponsor. And to the day she died, Eleanor Rickover supported the USS Rickover. So I was very fortunate that my sponsor, our sponsor on the Rickover, if I had a picnic, she'd drive down from DC, go to the ship's picnic. I used to send her our little quarterly newsletter, and we had a Sailor of the Year program. She always sent the Sailor of the Year $500. And I would say Terry Stackley is very similar to Eleanor in terms of her enthusiasm of the role that she's taken on.
In 2026, the Idaho and boat sponsor Terry Stackley will complete the third milestone, welcoming Idaho to the U.S. Navy, a tradition known as commissioning.
And it officially becomes a USS. If you see all the names of the ships as USS, before that they're called PCU, Pre-Commissioning Unit. They're not a USS ship until they're actually commissioned.
Well, how is it that Idaho, a landlocked state, has a nuclear submarine named Idaho? If any state has a DNA connection to the nuclear navy, it is Idaho.
Former U.S. Interior Secretary Dirk Kempthorne is chairman of the advisory board to the USS Idaho Commissioning Committee. The committee is responsible for bringing the future crew to Idaho and showing them the surprising role this landlocked state has played.
Never have I been on another submarine or been exposed to another submarine with the commissioning committee as involved as ours has been. And really providing a means for us to come here and learn about Idaho, and for the community and the state of Idaho to learn about us. It's unlike anything I've ever seen before.
Let it be forever. Let it be forever. Let it be forever. Sink boats, cut across.
The fact that the United States submarine force is the most silent in the world, well, that doesn't just happen. That means you have the finest of technology. Where does that technology come from? Idaho, Lake Pend Oreille, Bayview, the Acoustic Research Center. Again, the role that Idaho plays in the well-being of the nation, making sure that our submarines are the most silent and most technologically advanced.
Crew members of PCU Idaho had the opportunity to visit Farragut State Park in 2023, visiting the place where sailors were trained during World War II. A short distance from Farragut is the Acoustic Research Detachment, ARD, where acoustic signatures of naval submarines are tested and improved.
This is probably the most important facility in the entire Navy because of what we have with large-scale models that can very accurately represent full scale, and then the test environment we have to test them in.
All of this in Idaho is part of the past and future Navy, just like the reactors in the Arco Desert.
And a big part of the Naval Nuclear Propulsion Program here is in Idaho. Tremendous partnership is what we've had, and that relationship is really provided for national security and world security, and it's really something to be proud of for both the state of Idaho and the Naval Nuclear Propulsion Program.
Funding for this program is made possible with the support from the James and Barbara Semino Foundation, Ann Balakay and Louise Nelson, Judy and Steve Meyer, and from contributions to the Friends of Idaho Public Television and viewers like you. Thank you.